All right, that's enough of the applause. These are just the notes for section 1.7. Talking about perimeter, circumference, and area, really just the basics of it for just a couple of generic shapes. I think most of you are going to be pretty familiar with a lot of these terminologies and a lot of the equations also. So take a second, copy these down if you need to. Like I said, this should be pretty familiar. But basically, perimeter, it's just a distance around. So you're just going to be adding up the side lengths of a polygon. The circumference is the same thing, but it's a term that's only applied to a circle. The circumference is the distance around a circle. For the circumference, we do use a capital letter C. For perimeter, most of the time we'll just use a capital P. The area is the amount of surface covered by the material. Okay, that kind of implies that it's a two-dimensional space. A lot of times we use a capital A for area. Perimeter and circumferences, they are distances, so we use just normal units of length. A lot of times they're shorthand, feet, inches, meters. An area, like it says, it's a two-dimensional shape. So we have square feet, square meters, inches squared, a couple of different ways to say it. Okay, again, like I said, we're going to just do some of the basic shapes. We're going to go into a lot more detail later on in the year with areas and circumferences, that kind of stuff. But take a second, copy some of these formulas down. Okay, for a square, perimeter is just a distance around. A square, all the sides are the same. So we got this 4 times S. A square and a rectangle, as far as area is concerned, they're basically the same formula. A rectangle, you're used to that, it's length times width. A square, all the sides are the same. So one side is S, all the sides are S. S times S for length times width, there's that S squared. Just a specific formula for area of a square. The perimeter, it is length plus width plus the next length plus the width, the next width, because opposite sides are the same. But you can simplify that to the 2L times 2W. And again, area, length times width, kind of basic stuff. For a triangle, you got 3 sides, so the perimeter is just the 3 sides added up. Not a big deal there. The formula for the area, we'll go into this a little bit more detail. I'll show you some things about where that comes from later on in the year. But for now, 1/2 base times height. Pardon me. Base and height. The key thing about it, and as it says here in red, they have to be perpendicular to each other. In this picture, the base is that bottom side. The height is this, going from one vertex down to that side that we call the base. It's got to be perpendicular. It absolutely has to be perpendicular. If you look at the square and the rectangle, the 2 sides, they're perpendicular to each other. The length and the width, they are perpendicular to each other. When you're talking about an area of a polygon, the base and height have to be perpendicular. Okay, for a circle, slightly different formulas. We have 2 of them for circumference. The 2 pi r, that's the most common one. If you know the radius, multiply it by 2 pi. If you know the diameter, pi times d. Now, the diameter is twice the radius. It's not on there, but it's important to know. The area of a circle, pi r squared. Okay, so just a couple quick examples. Find the perimeter and the area. So looking at this first shape, we have, and again, I want you guys doing these on your own. Try them on your own first, hit pause. But we have a rectangle. You can tell from these 2 tick marks and these 2 tick marks, these sides are the same. Single tick mark, single tick mark. Those 2 sides are the same. So for the perimeter, what we have is just you add up all the side lengths. There is a shortcut way. We have 2 of the 14 lengths, plus we have 2 of the 9 lengths. So let's see, that's going to be 28 plus 18. What was that? 36, 46. There's our perimeter. The lengths that we were given was in feet. That little, I forget the name of those things, but that means feet. You could just put FT like it shows in the picture, but that also says the same thing. Area is length times width. So we got 9 times 14, 90 and 36, 126. But it's an area, so it's a unit of length squared. Okay. For the triangle perimeter, you just add up all the sides. 30 inches. For the area, it is 1/2 base times height. The base and height have to be perpendicular. There's a perpendicular marker. So this side 12 is perpendicular to the side that is 5. We'll call this one the base. We'll call this one the height. It really doesn't matter what you call them, but they got to be perpendicular to each other. So we got 1/2 base, which is 12, times the height, which is 5. And that gives us 30. The unit of length was inches, but we're talking about an area, so it is 30 inches squared. Okay, for a circle, same thing. Hit pause, try it on your own. Okay, this is the radius. It's the distance from the center of the circle to the actual circle itself. So for the circumference, our equation is 2 pi times r. We got 2 pi times 32. When you're dealing with pi, you kind of treat it like it's a variable, like the letter x. You put it at the end. So 2 times 32, we have 64 pi. This radius was a centimeter. Our circumference is a distance. So we have 64 pi centimeters. This is the exact answer. May as well just leave it like that. You're doing more work to get a decimal approximation. For the area, change colors here. For the area, our formula is pi times the radius squared. Again, we know our radius. It's 32. So order of operations says we're going to square that. 32 squared. I'm grabbing a calculator here. 1,024. So our area is 1,024 pi. Again, area, so centimeters squared. And that's it for those. Pretty straightforward. It doesn't get too much more complicated with these kinds of problems. All right, where it does get a little bit more complicated, and that's not too bad, is this kind of story problem. So again, hit pause, give this problem a try. You got the area of a triangle. So right there, area of a triangle. Start with the formula. Okay, the area is 338 square yards. The height of the triangle is 4 times its base. So we got a couple of pieces of information. The area is 338. So I'm going to plug in 338 for area at 1/2. Now we're told some information about the base and the height. It says the height is, so h equals 4 times its base. So h equals 4 times b. So what I'm going to do is basically like a system of equations. I'm going to take the h out of our equation, plug in 4b. Okay, the question is find the height and base. By making this substitution here, we got one equation, one variable. We've been talking about it a little bit with all the problems we were doing in the previous sections. We can solve this thing for b. So we got 338 equals. This is all multiplication here, so we can change the order any way we want. 1/2 times 4 is 2. B times b is b squared. In order to solve for b, get the b squared part by itself first. So dividing both sides by 2 just gives us a b squared on the right side. 338 divided by 2, 150, 169. Now to solve for b, we take the square root of both sides. Square root of 169 is 13. There's our base, part of our answer. What we're missing now is the height. The height is 4 times our base. Our base is 13. So 4 times 13 is 52. All right, so the only thing we're missing is the dimensions. This problem started off as an area of square yards. That means each of the lengths was in yards. So the base was 13 yards. The height is 52 yards. All right, that's it for this one. There's one more video with slightly different stuff. Please watch it.